All right, for these three, we're just trying to get all the perfect squares out from under the radicals. We're trying to simplify these basically. So I'm going to do these kind of as quickly as possible. 420, I'm looking for two numbers multiplied together equal 420, and there really aren't. This is the same thing as 60 times 7, I believe. Yeah, that'd be 420. So 60 times 7. This is 6 times 10. This is 2 and 3. And this is 5 and 2. This 2 can come out, but the 3, the 5, and the 7, because they don't have a pair, and for square roots we need a pair, for cubed roots we need 3, for fourth roots we need 4. What this is going to end up being is 2 times the square root of 3 times 5 times 7. So 15 times 7, 70 plus 35, 105, 2 root 105. Okay, and that's A. B, so B, 4 root 84. 84 is 4 times 21. 21 breaks to 7 and 3. Those are primes. They don't go anywhere. And 2 and 2. So this is going to end up, we get to take a 2 out, and we have to multiply it by what's already out there. And so 2 times 4 is 8. And we're left with this part inside. So 8 root 21. And that's that answer. And then C. C, you can kind of take a couple of different approaches. You can either multiply them together first and then take out as much as you can, or you can take out the factors first and then multiply them together. Either way really works. One way may be more efficient. But what I'm going to do is I'm going to take out I'm going to see what I can get from the 32, x to the 5th. And I'm going to see what I can get out of my 24x to the 7th, and then see if anything else will come out. It's probably more efficient to multiply them together first, but I don't know. Okay, so I have a pair of 4s common to that one. This is x times, so this is x squared times x cubed. And the x squared is x times x, so I can get an x out of that. X cubed is x squared times x, so I can get another pair out of that. So I'm going to get x squared out of that and leave an x. And so what I end up with is 4 square root of 2x. 4x squared. Let me rewrite that. On this one, I end up with 4x squared times the square root of 8x. And if you want to double check that, you can always, not 8, 2x. I broke the 8 down into 4 and 2. So this is what comes up. It stays in. You can square what's on the outside. That would give us 16x to the 4th. 16x to the 4th times 2x gives us 32x to the 5th. So that one's good. And then that's going to be multiplied by this one. 24x to the 7th. 24 is 12 and 2, 6 and 2, 3 and 2. So these two 2's can come out. This 6 is going to stay inside. And then with the x, we have x to the 7th, which is x to the 2nd times x to the 5th, which is x to the 2nd times x to the 3rd, which is x to the 2nd times x. And so I've got 2x to the 2nd power, and then I also have 2 single x's with one x left inside. And so I'm going to get 2x cubed on the outside and 6x left on the inside. Okay, again, I'm going to square this and see if that would work. So that'd be 4. 4 times 6 is 24. And x to the third power squared would be x to the sixth power. X to the 6 times 7 times x is x to the seventh power. So we're good there. Okay, this isn't quite simplified because I can multiply this together and this together, and I can multiply this together and this together. And so on the outside, I'm going to have 8x to the fifth. And on the inside of the radical, I'm now going to have 12x squared. Well, that 12x squared I can pull out. So that's 4 and 3. That's 2 and 2. So I get a 2 out. And x squared is x times x. And so I can pull that out. So I can pull out another 2x. 2 times 8 gives me 16. X times x to the fifth is x to the sixth. And leaves the square root of 3 on the inside. And so 16x to the sixth root 3 is the final answer for that one.